welcome to this video. So in this video we shall be looking at how to implement stacks. Of course, a stack is one of the data structures besides queues, arrays, linked lists. A stack is one of the linear data structures. Now a stack is a linear data structure in which elements are added and removed from one end called top. A specific example is when you have plates. When you have a pile of plates, you add on top, and when someone is to remove a plate, they still remove the plate on top. So it's one of those real-world examples that you can look at that demonstrates how a stack works. Now, for us to implement stacks, there are different ways we can implement stacks, but in this video we shall focus on how to use arrays to implement stacks. Okay, so just like we've said, that a stack is where you add and remove elements from one end called top. So basically we will look at how best can we for example implement a stack. So I'm going to start straight away. First of all, we shall create a class called stack, and it's where we shall include in our operations. There are three basic operations for stacks. One is a push, where you add elements into the stack. Another one is pop, which means removing elements from a stack. The third one is pick or pip, which returns the topmost element on the stack minus removing it. So we use a class because a class has objects. We can instantiate our class and be able to access the operations within that class. So I like using OOP to demonstrate, for example, how you can implement a stack. So we shall create a class called the stack, and this stack will be a stack of numbers, for example, but we've said that a stack has an end where we add and remove elements, and this end is called top, and top is an index of the topmost element. So in this case it will be a numeric value. So in this case I will use an integer to indicate our top or track, which index is the topmost in our stack. So I will say int top, and then we terminate. Then next, I've said that we shall use an array, and this array specifically will be an array of numbers to implement our stack. So in this case, since the numbers I'm going to use int as the data type. So I can say int array, then into a size. In this case, you can specify which is going to be the size of the array. So I can define here constant that will be the maximum size of our array. So define maximum maybe 5, and then here I will specify the size of the array to be the maximum size that we have declared. So meaning that our array is going to have a maximum, going to be having elements, and they are going to be 5 as the maximum value. So we can go ahead and create a constructor, because we need this constructor. By default, when you create a stack, it is empty by default. So how do we know that a stack is empty? When top equals null. But we can also, when top equals -1, since top we've said it's an index, and therefore it is okay for us to use -1 to indicate that actually the stack is empty. So at the point when you're creating a stack is empty. So that's why we go ahead to initialize top equals -1, because remember, the constructor is going to run once at the time of creating the application, or when the application starts is created first. So it meaning that at the time when a stack is created, of course, you know that it's going to be empty by default, and so we go ahead and use a constructor to initialize top to be -1, indicating that the stack is empty. So I will say top equals -1. After that, I can go ahead and create operations that we've seen we've talked about. One is push, which is used to insert an element into the stack. Next is pop, and the third one is pick, okay, which returns the topmost element. And of course for push, you're just inserting an element into the stack, so you do not return any value. After pushing the element or after adding the element into the stack, you don't come with any value. So in this case, we can make the return type for our function push void, because we do not return any value. So I'll say void push, and of course our array is we've created an array for numbers, so meaning that we are going to push a number into our stack, so it will be a numeric value. So it is very okay for me to go ahead and push a parameter, insert a parameter for push as a numeric value, since the array has numeric values. So I will say int maybe value, which is a number. So before you insert an element into a stack, you need to first find out if it is empty, if it is full, because if it is full, then it means you cannot add any more elements. For example, here we are using an array, and this array can only contain 5 elements as the maximum, meaning that you can only add 5 elements. If you push beyond, then you expect that you're going to get an overflow. It's like when you have a jerrycan of water and you can only add 5 liters of water, so you cannot power more than 5 liters into that jerrycan. So the same concept here, that if you have a stack, and this stack you're implementing it using an array, and this array can have maximum number of items or elements as 5, then you cannot add the thicks. On adding thicks, you will experience or encounter an exception, which is an overflow. So we will first write a condition to make sure that we do not insert this value when actually the stack is full. So how do we check this? If stack is full, we use if top equals max minus 1. Okay, we say top equals max minus 1, and here we can say stack overflow, meaning that you cannot add any more elements into our stack. Okay, so this one is to check if the stack is full, because if it is full, we can't add any more elements. Else, or you don't have to have else, it's better to, you can go ahead and use else. Now else means that the stack is not full. Okay, if it is not full, then it means we still have space where we can insert our value. So what do? We need to increment top first. And so we can say top equals top plus 1. Okay, because now it is going to be on the next index. For example, if the topmost element was at index 3, if you're adding, to mean it's going to shift from 3, the topmost will be 4, and so that's why we first increment top, and then after we can go ahead and insert the value at the top. So we shall set our array into top equals the value that we are inserting. If you don't want to use this approach, you can summarize this into one line, and instead of saying this, you remove this and you say array into plus plus top, meaning that the value of top will be incremented first before you assign a value, which is the same concept. So we've created a method for pushing our values into the stack, and so next what we are going to do, we are going to create one push inserts an element into the stack. So next we are going to create a method that is used to print a stack. So we can just create one called print stack, and we use this one to list or display elements in a stack. Okay, so also when you're listing, you don't expect this function to return anything. It's just going to list to display the values in a stack. And therefore, so what we are going to do is make return type for this function as void. So we shall say void print stack, and of course it does not take in any values. So we shall use a for loop to make sure that we iterate through our stack, and we display these elements. So for, we start with index since we are using an array, index equals 0, then I less or equal to top, because we have to iterate until we reach the topmost element, and then we say I plus plus. And therefore here we can count, we can print the values. Remember, we are using C++, so we can use count, then into array, which is our array, then into I, and we can go ahead and format our data, and then we terminate. So in this case, we have created a method called print stack, and this print stack method is going to help us print the elements within a stack. You start with when index is 0 and index less or equal to top, because you have to move from 0, which is the first index, until the topmost index, which is in this case top. If you want, you can use any variable here. Doesn't have to be I. You can use index to indicate that it is your index. Of course, you're using an array to iterate your stack, and therefore you can use index to indicate that it is an index. So in this case, we can call our operations within our stack, within the int main, so we can instantiate our class stack and be able to call these methods, for example push, and we insert elements into the stack. So we shall go into the int main and say stack s. So we've created an object called s. Okay, but of course now the reason as why you see s is not saying that it's non-public, because a class in C++ is private by default, so it cannot be accessed. Now we are using a constructor that we've created to create an object for the stack class. So this is an object, this we are using a class, but of course, as I've said, you could use a constructor in creating an object, but this constructor is private by default, as we all know that classes or members within a class in C++ are by default are private. So in this case, we shall we shall use public as the visibility modifier, and by putting public here before a constructor, this public as a visibility modifier will transcend down. Even push will have public as the visibility modifier, and also print stack. So you do not have to prefix it on every function that you have, or any data member. So that's why we are now not able to see the error. So in this case, we can access our method. So we can say s.push, and we push maybe 10. We say s.push, we push another value 20. We say s.push, we push another value 30. So meaning that we've pushed 3 elements, that's 10, 20, and 30. Remember, a stack follows LIFO principle, last in, first out. So we expect that the value to be on top is 30. So we can print these elements using our function called print stack, which we created within our class. So we can say print stack, and then when we print, we should be able to see 10, 20, and 30. So when we execute this, we see our values 10, 20, and 30. So that's how you push values into your stack. We can go ahead and create another method, a basic operation that we do on a stack, which is pop. Pop, just like I said, is used to remove the element from the stack. So, and remember, when you're popping, you remove the element that is on top, because remember, last in, first out. So if we last added 30, then it means if you are popping, if we are deleting or removing, we are going to remove the element which is on top, and that is 30. So normally when you pop, you return the element that you're going to remove from the stack. So we are going to call it int, since we are dealing with numbers. So we say pop, but before we pop, what you need to first establish is you don't want to pop when the stack is empty, because you cannot delete what does not exist. If you need water, you can't go to a jerrycan that is empty. You need to first establish that actually that jerrycan has water. So a stack also, we need to make sure that a stack is not empty. And how do we check that a stack is empty? Of course, in our constructor, we had seen that by default, when you create a stack, it is empty, so we use top equals -1. So we use the same condition, that if top equals minus 1, then we know that the stack is empty. So here it will be stack underflow, meaning that it is actually empty and we cannot perform a pop operation. Since we are returning a numeric value, as you see in the return type for pop is int, we can return -1 to indicate that the operation is not successful. Then we go to the else part, or even if you don't use the else part, because if the condition is met, we return this. Else it will have to first get the value that is on top before it removes it. So it is array into top, and after that we can decrement. Remember, if the topmost is at index 4, when you pop, it is not going to be the topmost. Now the topmost will be 3, so we have to decrement top by 1. So we shall have to say top equals top minus 1, and then we return the value that we've popped. Okay, so in this case we shall have completed our operation for popping or for removing an element on from a stack. So we can demonstrate that we've popped our stack by calling this method pop. So I'll come down here and call it. I can call it before after pushing 30. I will say s.pop. Now when you call s.pop, what it will do, it will remove the topmost element on the stack. Currently the topmost element is 30 because we added 10 first, 20 and 30. So now when we pop, we expect to pop 30 because it's the element on top, meaning that when we print our stack, we expect to have 10 and 20 as the values in the stack. So when you execute this, you realize that the elements that we have now, we have 10 and 20, meaning that 30 has been popped from the stack. So the last operation that we can perform on the stack is pip. Okay, is pip, or what you can call pick or pip. Any of those words or any of those terms you can use, but normally we use pick. So pick returns the topmost element from a stack, or on the stack minus removing it. It returns the value which is on top and does not remove it. So in this case, we are still doing our arrays has numeric values, as you can see, integers, and therefore we will declare the return type for a function pick as int. So the first thing we need to do is to make sure that you don't want to return when actually your stack is empty. So the first thing is you need to make sure that it's not empty. So shall I say if top equals minus 1. This is the condition that we said that we use to make sure that our stack, to check to confirm that the stack is not empty. So of course we can say stack is empty, then we return -1. Return -1 to indicate that the operation is not successful. Else, what do? We return the value on top. So we say return this on top, and of course this else part is not necessary, so we can just say else it will go and return the topmost value. So what does this one mean? That if the stack is empty, it's going to return -1 and print the stack is empty. Okay, else is going to return the topmost. If it is not empty, it's going to go and return the topmost element on the stack. So we can go ahead and call our method pick, and we see which value will be returned. So in this case, we can come here and say count the topmost element in the stack is, and then we say s.pick, and then we terminate, then we say end error. So the topmost element in this case is 20, because remember we popped out stack, we called pop, meaning S30 was removed from the stack, meaning that the topmost element is now 20. So if we run, we expect that the topmost element will be 20. So we can come here and run, and we can clearly see that the topmost element in the stack is 20. If we comment out the method for popping, then it means that we have not deleted 30, meaning that the topmost element in this case is going to be 30, and even when we print, we expect now 30 to be there because we've commented out the pop operation. So that's why when we run and look at my console, you realize that we have 30 back because we've commented out the pop function, and now we have 30 as the topmost element. So this is basically, you can build a simple stack to demonstrate how its basic operations, or how a stack operates, or how a stack operates. Remember, we said that it is a data structure where elements are added and removed from one end called top. So how did we achieve that? We first created our class and created two variables. One is top, another one is ARR, which means our array, and of course the array is going to be having the maximum of 5, which we've indicated this array is not going to go beyond 5 elements. Then next we created a constructor, and we are saying that top by default equals -1, because by default when you create a stack it is empty, and we can indicate that it's empty when top equals null or -1. Since we are saying that top is our index, so it's okay for us to say equals -1. To push an element into a stack, to push the element into the stack, of course we say that the first thing we need to do is to check if it is full, because you cannot add an element when a stack is already full. So we use the condition if top equals max minus 1. Okay, top equals max minus 1. But remember, this is an index. Since we are using the array, okay, to the topmost index will be maximum size, then -1. And once we have that, then it means that our stack will be full, and once it is full, we cannot add any more values into the stack. So once we establish that it is full, we print a message that the stack is full, or you can say stack overflow. Else you add the value at the top. By saying ++, it means you first increment the value of top and then assign the value. So that's how we do a push. For a pop, you cannot remove an element from a stack when it is empty. So the first thing we establish is check if our stack is empty, and if it is true, then we shall say stack underflow, because you cannot remove what does not exist, or you cannot remove an element from a stack when actually it is empty. So if it is empty, we print that message stack underflow and then return -1. Else, we first access the element that we are going to remove from the top, then we decrement the top, and then we return the value, because pop has to return the value that is going to be deleted. Pick returns the topmost element. The first thing that you do, you also need to make sure that you cannot return the topmost element when actually the stack is empty. So you need to first make sure that the stack, you use the same condition, top equals -1, and if it is true, that means the stack is empty, so we return -1. Else, then we return the value on top, which is our array into top. And of course, we also wrote the function for printing our values. We start from index when it is 0 until we reach the top, which is the index of the topmost element. Then we increment, and then we access the elements in the array or in our stack using the array name and then the index. And what we are doing here is first of all, we've instantiated our stack by using the constructor that we created here, and after instantiating, the object name is s. Therefore, we can access the methods that we created in our class stack through the object that we are creating, which is s. So we are creating s.push and s.pop, and also s.print, which is printing the elements in the stack, and also s.pick, which returns the topmost element. So this is basically how you can use C++ to demonstrate how a stack is implemented using an array. So thank you very much for watching this video. I hope you've learned something, and can't wait to see you in the next video. Thank you very much, and please subscribe to our channel so that you keep getting a notification whenever we upload a new video. Thank you very much and see you next time.